Okay, so if we're finding the x-intercept and y-intercept, if we're given a function in vertex form, to find our x-intercepts, we set it equal to 0, and then we can just solve for x. So we use the opposite of PEMDAS. You start with adding and subtracting, then multiplying and dividing, and then your parentheses and exponents. You always do the opposite of what's actually happening in the function. So the first thing that's happening is we're subtracting a 2. We can't do our parentheses yet because that's last, so we start adding and subtracting. The opposite of subtracting 2 is adding 2 to both sides. So we are left with x plus 3 squared on the left side equals 2. Then we look and we have an exponent. So what we need to do is the opposite of squaring something is square rooting something. So we're going to square root both sides. And we get x plus 3 on the left side, and we get plus or minus square root 2. Anytime you square root a number, you get two solutions, a positive solution and a negative solution. Let's take a break and look and see why that is with numbers we're more familiar with. If we have the square root of 9, we get plus or minus 3. Well, why? Well, if I square a positive 3, I get 9. If I square a negative 3, you still get a 9 because that negative is being multiplied by itself, so it becomes positive. So that's why we end up getting a positive and a minus for any time we square root something. Okay, so from here, we subtract 3 on both sides, and now x is by itself, and we're left with negative 3 plus or minus square root 2. We're going to leave it in radical form because it gives us the most accurate information. But we do need two solutions because quadratic functions have two solutions. So when we do this, we have x equals negative 3 plus square root 2, and we get negative 3 minus square root 2. And x-intercepts are always a point, and it's where y is 0. So our x-intercepts for this function are negative 3 plus square root 2 comma 0 and negative 3 minus square root 2 comma 0. Now if you're going to plot these points, then yes, it would make sense to put them in decimal form, but since we're just asking for the x-intercepts, we want to just leave it in this form. For y-intercepts, all you do is you take the given function, and the y-intercept is where x is 0. So we put 0 where x is. So we have 0 plus 3 squared minus 2 equals 0. 0 plus 3 is 3, so we get 3 squared minus 2 equals 0. 3 squared is 9, and when we do 9 minus 2, we get 7. So our y-intercept is 0, 7. And that's how you find the x-intercept and y-intercept of a function if it's in vertex form. If it's in standard form, all you have to do is factor it out, set them equal to 0, and solve for x. Roots, solutions, and x-intercepts all mean the same thing.